Volker, Dusch.
Sorry.
Hello. Thank you so much. It's a pleasure to be here. Haven't been to the UK in quite a while, and I'm super happy to be back. So we have a lot of stuff to get through. So hopefully I'll talk too fast and don't bore you. If I bored you, I failed. Otherwise, I'm happy. Hi, I'm Volker. I do this PHP thing for about 20 years. For a bit of context, so for where I'm coming from when I say things, I tend to work on applications with long life cycles, like millions of lines of code, tens of years of history, stuff like that. And I currently work at Tidewise on PHP performance tooling. That's why, where my interest of the topic led me, and the company also allows me to be the release manager for PHP 8.5. So for those that have already upgraded, thank you for using my tarballs or what people build out of them. And yeah, and I work as a head of engineering and full stack engineer in the sense that everything that goes wrong is my problem and I can maybe fix it. And so let's get into it. Performance is like a very wide and topic that you could talk days and days for. So we're going to do a couple of specific things. You can talk about database tuning, you can talk about pre-merge optimization, distributed systems, observability. Thankfully, Florian already gave a talk about the 4 pillars of observability in the last slot, and thankfully we have definitely coordinated and made sure that we don't give you the same content, and it didn't just happen by accident, but it worked out perfectly, so there won't be any repeats. And my goal for today and what I want to do is I want to help you to build a mental model of how PHP executes code to inform your reasoning when you think about why things are slow. I want to help you measure performance more correctly, create provable results, make sure that what's happening is actually happening and that you're not just seeing ghosts. Like I said, inform your performance reasoning and help you find bottlenecks in your application. So to start off, what happens when you execute a PHP script? We're skipping over the web server part. That's a different topic. You can read a bit about FPM tuning on our blog if you want, but what happens when you execute the thing? So, I mean, you can check it out yourself with strace. I'm gonna not show you that massive output that comes out there to see all the Linux system calls, but basically what's happening is the PHP process boots up, and then the PHP CLI API starts up and starts initializing things. So for the web server, this would just be another server application interface. We allocate a bunch of memory to do all the initial stuff that we want. We set up the signal handlers so that you can kill your process and send signals to it. We load a bunch of ini files into memory. We load a ton of time zone data, chunk more stuff that's going on. And eventually, 40 milliseconds later, we read the first PHP file. And then what happens from reading the first PHP file is lexing and parsing. So we create a token stream out of that gets turned into an abstract syntax tree. That gets compiled down into what PHP calls an array, so an array of opcodes. I'm not sure if there is a canonical version of what that means. I'm going to say operation codes or things that encode operations. Basically think of this as if you've ever seen JVM bytecode or LLVM intermediate representation or assembly, sort of like this. We're going to have a look at a couple examples. Then there's an optimization stage that runs on that stuff. If you have opcache enabled, if you don't have opcache enabled, this optimization doesn't happen. And then the PHP VM starts executing these opcodes and these instructions. So, and now we're at the point where your code runs. It fetches one of these lines, calls the handler for this opcode, calls into C functions if it needed. Then it immediately cleans up memory if a variable gets deallocated, like PHP does this ref counting thing that the second there's nothing pointing to a variable anymore, it gets immediately cleaned up. Sometimes the garbage collector runs in case a bunch of variables point to each other in a circle. That's something that the ref counting can't solve. So for that, we have the garbage collector since 5.3, I want to say, I don't remember. And then eventually, or usually very soon, you come to an include and require, and we're going to do the whole thing all over again, and all over again, and again, and again, and again. And this is why we have opcache, so that we don't have to do this whole lexing and parsing and optimization phase for every single web request, because that actually takes quite a bit. And so what you can do with PHP without installing anything extra, you can actually look at these opcodes that PHP generates. And sometimes this can be useful to understand how PHP views your program. And yeah, these very easy to remember constants that I definitely always remember and don't have to look up every single time, you can pass to opt level debug, and then you see how this code looks. So we have an example script here. We get a random integer that's 1 or 0, and then we have an if false statement, and then if foo is true, we echo something. How does that look to the engine? This is how this looks. So if you've seen assembly or pseudo-assembly, this might make some sense to you. And the main thing here is we initialized this function call. We send it the 2 parameters. Then we do the call, and we assign the result. Then we say, if bool false is true, if bool false is true, yes, then is false, then jump over this, sorry. Otherwise execute never. And then we have the second if statement here. If we now turn on the optimization for this, this is how this looks like. So as you can see, there's just a couple lines missing because PHP is smart enough to say this is always false. I don't even have to generate instructions for this. This is a very trivial example. Like you don't write an if false in your code, but PHP is a bit smarter. Just none of the examples fit on a slide, and I didn't want to make you read like through half an essay of assembly code. But there's some other smart things PHP does to make your code a bit faster. And the other great thing about opcache is it only does this compilation once, and then it stores these compiled scripts into memory so that we don't have to do this every single time. This shared memory is usually like in your mod PHP Apache process, or in your PHP FPM master process, or in whatever PHP runner you're using. And the important bit, just to reiterate, is if you don't use opcache, you don't get all this optimization stuff. And that is maybe one of the easiest to tweak and optimize things that you can do for your code base that can have massive improvements. You don't expect the world. Sometimes it's like 2%, sometimes it's 5%, but we've seen cases of like 20, 50% speedups when people were doing really compute-intensive stuff that the optimizer is good at optimizing. Here is how this looks like. There is some configuration values to consider that all this stuff fits into memory. PHP has another fun feature called opcache intern strings buffer, which basically means you take all the static strings in your program and you only write them to memory once, and then you don't touch them anymore. So you don't have to allocate this memory every time you need that string. These strings are hard-coded strings that you have in your application, but these strings are also function names and other stuff that you don't want to repeat all the time. And this counts against your general memory consumption for opcache, but if you set these settings to a sensible value, then you'll be fine. And then opcache has some statistics. It tells you how many scripts are compiled. The default value for this is 10,000. Actually, the default value for this is 16,183, but don't worry about that. That's just a convenient prime number. But chances are your PHP application actually has more than 16,000 files these days, depending on the frameworks you pull in. And you might want to look at that and see if you have enough files and change that number. Otherwise, it will just churn through these files, and it will have to recompile like the least recently used files all the time. And that can actually lead to, quite a lot of pointless work that doesn't really need to happen, because you can put 100,000 of these into memory easily. Maybe in 8.6 we'll change that default. Some further reading if you want to look at this. And then you all know PHP has a JIT. I bet you that 90% of the people in the room don't run the JIT. Probably 99%. Like, this is just something that PHP doesn't enable by default, that when you turn it on, you run into some things that work a bit differently. And also turning it on hasn't always been so trivial, because you need to change a couple different settings that are explained here on the slide. That I'll leave that exercise to you for later. The JIT can be really cool. It can be really worth it for long-running scripts. Like, we've seen performance improvements for this, running PHP stan, running some workloads for PHP unit, but it's not always the case that this makes things better, especially not for like short-lived web requests where it doesn't really have a lot of time to do the JITting. So how does this look in practice? And since we all just had lunch, we're going to do like a physical exercise now. Bear with me, it's not going to be hard. Which of these 3 lines, A, B, or C, is the fastest when you execute it in PHP? I'll give you like 15 seconds and take some water while you think about that. Who says A? Raise your hands. Cool. Who says B? Fantastic. Who says C? Who says I shouldn't think about pointless micro-optimizations? Cool. I promise you there's a... and for the keynote today, who says it depends? Fantastic. Over 90% of you are right with at least one of your answers, but I'm not showing this to you to show you what actually is faster, but how to reason about this and to tell you a bit of a story. So don't worry about that. I haven't gone crazy. So in PHP 8.3, this is the fastest by like a lot. This is 40% slower. This is 50% slower. I'll show you how I generated this output later as well. And in PHP 8.4, these two are exactly the same speed, and this is slower. So let's look into what happened. How did we measure this? And how can we use what we just learned about opcodes to understand this, and what changed in 8.4? Here is the benchmark script in case you want to know, because I believe in reproducible benchmarks, and when I make a claim, I want you to be able to go ahead and verify that, just in case you don't believe me. So this, we just get the first argument of the server, and we call the function that's named that. So like I call this with A, B, and C, and we get that function name, and then we call that function. We do a bunch of iterations. And now let's look at the opcodes of this script. So for this thing, for A equals foo bar with dashes in between and string interpolation, PHP does something like some here's the initialization for this. And then to make the result string, PHP does something that it calls a rope builder. If you've used Java, think string builder. The basic idea is we allocate one contiguous region of memory and we replace all these individual strings in there. And for the concatenation case, we do the same initialization, and then we do a concat. And a concat works that we look at how big the individual parts are, we allocate a region of memory, then we copy both of these things in there, then we free those small parts, and then we do this all over again and again and again. So if you have a loop where you append 1 byte to a gigabyte worth of data, you're allocating a gigabyte worth of memory every time. It's not exactly like that. There is some buffer in these strings, so that the performance of that has been optimized a bit. But as a over-dramatized, is that a word, example, that's what's happening here. And then for sprintf, this is how this looks like, and we just make a function call. And each function call comes with a tiny bit of overhead, and that's why that's slower. So what changed in 8.4? If we look at this, if we look at the \sprintf opcodes in 8.4, this is how this looks like. And you see the exact same opcodes generated for this code in 8.4. And basically what happens is this sprintf is just optimized away by the compiler. Like this isn't even an opcache specific feature. Most of the things are, but this one is just a thing that the compiler recognizes, like, I know what sprintf is, I can optimize this out. There's a couple caveats in there, like this only works if you have a string completely made of %s and %d placeholders. So like no fancy formatting, that needs the real function to do the real work. And you need to use \sprintf, not just sprintf, or you need to use function sprintf, because otherwise PHP can never know if sometime later in your script, in your namespace, you define a function called sprintf, and if it has to use that instead of the global function. So by using the \, you tell PHP always use the global function, and then these optimizations work. If you have questions on this, why do I have to put this \, there, and how does this work? That's okay, we all have. We wrote a post about it, and you can look it up on the slides later. Yeah. So takeaway, don't worry about this stuff. If this is actually a problem for you, please let the PHP team know. This is something the language can optimize. You don't have to do this. Please write code that you find maintainable and readable. And if something is like slow to that extent, And if there is like an easy win there, people who usually will pick that up. There's a couple more optimizations that I could go in that happened in the same way, like comparing things to an empty array. But yeah, PHP gets better every version, and people thankfully put stuff in there just to make nice code to be the most performant option as well. Cool. So what's the hardest thing about performance optimization? Like, yes, you have to sometimes know how to tweak a kernel setting, or you have to understand how database indexes work, or you have to figure out why this one microservice in your distributed system has this specific issue. But the hardest part is figuring out what's actually the problem and which part to optimize. And like once someone tells you like, hey, if I do exactly this thing, this piece of code, this is slow, then it's like, okay, cool, now we can fix it. Then it's like deciding if it's worth optimizing. Like, oh, I think this piece of code is slow. Okay, cool. Are we going to save like 5 seconds of CPU time next day, or can we turn off 50 servers? Like, what's the impact of the work that we're doing here? And then, especially in bigger organizations, also being able to prove what you've done and to validate those results and to say like, hey, I've made this small change that saved us $1 million this year. Promotion. And yeah, so I think once you have located an issue and you have like a script to reproduce it, and you can say, hey, this thing now goes a lot quicker, this saves us this much money, then like the fun part of like figuring out a solution to that is, I think, the enjoyable part of the process. Whereas like figuring out what's wrong, especially when someone says like the customer said the website is slow, like, okay, cool, which customer? Oh no. Which part of the website? Yes. Can you fix it? That's not the fun part of this process. So yeah, so validating results, like, can you reproduce the issue? If you can reproduce it, it's easy to tune and measure. Systemic issues need a different approach. We'll look at that a bit later on how you can do that. But let's go for, we have something that we can actually reproduce. How do we do this? So there's a ton of ways to benchmark something, and all of them have different use cases and different pitfalls. And this is the classic that you have probably seen or put somewhere in a code base, where you make like you create a micro time or an HR time, you do some operation, and then you measure how long this took. So like micro time uses get time of day for this with microsecond resolution. HR time uses clock get time with a monotonic clock and nanosecond resolution to get some better results there. Also, the value will never be negative. Did you know that if this is micro time, the value could be negative? It's a fun story. Doing this every time by hand can be very painful. And Dan is thankfully here, so I can point to him, and has written a tool called PHP Bench that allows you to do this in a more structured way. One of my favorite things about PHP Bench is this little section here, where it tells you that if you have Xdebug on, because then basically all the performance work that you do is completely worthless, because Xdebug changes too much about the cost of a function execution and like throws your measurements completely out of shape if you do any type of micro benchmarking. And the other thing is that it tells you if you have opcache enabled, which if you don't, your results might not reflect your production system, which hopefully has opcache enabled. Or if it doesn't, you also should know about it. But having these reminders built in a tool and having these best practices built by someone that cares about it for you is so much better than if you have to think about it every single time. Because like, even after years of doing this, I was looking at a piece of custom and I was like, this is impossible. Nothing of this makes sense. I can't reproduce. Ah, shit! I didn't unload Xdebug. Or like sometimes I forget to like enable opcache on the CLI, because you have to enable that on the CLI specifically with a separate flag. So yeah, what PHP Bench does for you is it runs the code multiple times. It gives you standard deviations. It gives you a structured approach. It gives you some joyful visualization that is actually fun to look at, instead of just like a bunch of var-dumped micro benchmark numbers that at some point make your head hurt. And then my favorite tool of choice for this type of work is a tool called Hyperfine, which is a command line benchmarking tool that I think has a focus on having human readable output and being understandable, and having great visualizations, showing you error bars, helping you with managing uncertainty, and it's very good at communicating results. And this is how this looks like. So you can just give this as many arguments as you want, and it will benchmark them against each other. So let's do something fun and benchmark how fast sleep is. And here for the first benchmark, we see sleep 1 took 1.02 seconds with error bars of 0.006 seconds. So this might have been 0.14 seconds, or this might have been 1.026 seconds. So yeah, the error bars just gives you an idea of like, what is the jitter on that? What's this uncertainty of this? And if you have very high range in how fast something is, then you know that you're not measuring this the correct way. And then it gives you this wonderful, that you can't see, but trust me, it's on the slide, sentence that says, sleep 1 ran 1.98 plus minus 0.01 times faster than sleep 2, which is a great sentence, because communicating that something is faster or slower than something else in human speech can be very complicated. Like if you say like, oh, something is 100% faster than something else, then someone goes like, oh, so the other thing is 100% slower. It's like, no, that's not how that works. Like this is somewhat complicated, and having a clear language to be able to clearly state that, and especially not having to think about it every time, is really nice. And so for our script, I see that the slides aren't big enough, I think, for everyone to be able to read this. But don't worry, if you want, you can look this up in the slides. But for the sprintf example, like the short outcome is that between like this sprintf call between PHP 8.3 and 8.4 is now 6 times faster by making this optimization. And the main thing that I wanted to show you here, this is also why it's on the top, is you can give hyperfine a parameter. So I say replace the placeholder version once with 8.3 and once with 8.4, and then I pass in my script. And here it just replaces this version placeholder, and then it runs the script with 2 different PHP versions. Same thing for comparing code changes. So we just have a script that takes a parameter that runs 2 different benchmarks, and we can pass that in. And yeah, this is something that I use a lot and that I'm quite happy with, to like generate somewhat provable scripts. These are also nice to share because you can usually share them in a gist. And if you talk to other people about it, like, here, this is how I measured it, and then people don't have to ask like 500 questions to make sure that you actually did it the right way. Or they can reproduce it and say, like, on my CPU architecture, this works completely different, which is a lot of fun. Yes, so taking a scientific and diligent approach there can be really helpful. Performance is something where we all have a lot of biases, and like, you ask someone why it's slow, and some people will say like it's the database. Some people will say, oh, we're using the wrong programming language. And like, okay, what are you basing this on? Vibes. I don't know. Yeah, a couple of things to consider as a reminder before we move on to the next topic. So before 8.5, you could forget to load the opcache extension. That was always a bit of a downer. Now this is compiled in, but you still need to make sure that it's on. That you can have a lot of caching in your application. If those are not warmed up, the first benchmark you run will be a lot slower, and then the other ones will be fast. If your CPU gets too hot, it will throttle. Great to measure things when, like, after 120 seconds, the complete performance characteristic of your app changes. PHP takes a while to start up. Like I said, like, PHP takes 40 milliseconds to start up. That can be a bit of an issue. This is not a PHP specific thing, like Python and Ruby also have startup times. Yeah, so cool. Let's talk about finding bottlenecks with profiling. So there is 2 main approaches. So one is like, when we run a script, we record every single function call that happens. The other one is something called sampling, where every 100 times per second, 1,000 times per second or something, we look at the process, see where it's currently in the execution, and record that. And for that, I want to tell you a small performance story with PHP unit, how you can do this. Like, someone reported a bug that the first test in PHP unit is slower than the other ones. And no matter which test they run first, that's always a bit slower. And we tried to reproduce that, and so we made like an HR time around the test runner in PHP unit. That was at an event with Sebastian together, and we figured out, yes, that's actually slower. And I told that story to my boss, and he's like, it's obvious what's happening. I'm like, not to me. Like, okay, cool. So like we used our profiler. Other profilers are available, and I will talk about them shortly. And this is how this looks like. Here is the PHP unit execution. Each of these little things is a test. So all the three tests do the same, but this is the first test, this is the second test, this is the third test. And here you have the composer class loader. And you see all these beautiful bars where the class loader is active in that test case. Yeah, so like the first test auto-loads some stuff, like it auto-loads your assertions and some other things. So of course the first test is slower. So what PHP unit in the starting from 12.4 now does for you is it actually loads all the stuff in your autoloader before it runs the test so that you get a reliable test execution there. So I said other profilers are available. There is a lot of cool tools. I don't have the time to go through all of them. My favorite one, and that I will show you a couple of screenshots of at the moment, is PHP SPX, which is a sampling profiler that ships with a great UI. There is Xhammer from Wikipedia. There is some others. There is commercial products like Tideway, Sentry, Datadog, Blackfire. Please don't use that. Nightwatch and AppSignal. Like, I like Tideways because they give me money. Otherwise, check out Datadog. Like if you're in a big organization and you want to support multiple languages, Datadog is a really cool tool. If you want to support someone that funds the PHP Foundation and does a lot of work on core, and you mostly run PHP, maybe check out Tideways or come talk to me after. But basically what you want from these tools is something like this. For every route in your action, or like for every controller action, or for every route in your application, you want to see how many requests did I have, what's my average response time, what's my P90, P95 percentile response time, how much memory does this use, and did I have any errors in there? Like you want some tool somewhere in your stack where you can go to your application and say, like, is this thing actually failing, and roughly how fast is it? And best case scenario, you also get a chart that shows you over time, so that after deployment, when the thing goes up by 10 times, you're like, maybe we did something there. Yeah, and then you can start looking for patterns. Like you get something that shows you like, hey, we're doing Symfony for this whole request. Here is a single Redis get request. Here is some other stuff that's happening. What's with all that empty space here? And like a tool can enlighten you with this data. So I think I have 15 minutes left. So yeah, fantastic. Good. Let's talk a bit about PHP SPX. So this is fully open source, runs on your own infra, and ships with a built-in web UI in the extension. So you have to only install the PHP extension and do nothing else to get all the features that I'm showing you right now. And this is a bit of a blessing and a curse because the web UI can be a bit clumsy to get working if you do CLI profiling. But thankfully, it also ships with other stuff for the CLI. And yes, so here is the same thing, but static. It also has a live view mode where while your program is running, you see the data changing, and that can be quite fun, especially for long-running scripts where you would like to get some insights while the script is running. But the main feature of SPX that I really like is the web UI. And sadly, this whole setup broke for me because it's a bit fiddly to get this working in the web server. Sorry for that. But you can generate a report, and then you get a flame graph. If you've never seen a flame graphs are really cool. You really should look into them. I'm happy to talk to you about flame graphs for about 2.5 hours before you get bored. And what this gives you two things. Here is a timeline of the request and which functions are running when in the request. But you also get this beautiful thing here, where the bottom row is the full time of your request, and then each of these functions is proportional to everything below it. So you get a very high level, very quick overview. You can click on each of these things to make it the bottom bar. And this is a fantastic way, once you've got over the initial hurdle of like trying to parse that data, to see what your process was actually doing. And you get all of this out of the box for like basically no overhead. Like basically no overhead if you run this thing on your development machine. Like it doesn't, just loading the extension doesn't cost you anything. And if something is slow, you can fire off a request, and then you get this nice insight for for free using an open source tool. And so summing up, what if you want to take something away from this talk, and if you want to take some homework away, find a profiler, any profiler. Use something free. If you want, look into Sentry or Datadog or our product, and just look into the web requests. Bonus points, write down before what you think your slowest routes are, or what you think like your biggest bottleneck is, and then be surprised that you were wrong. Because I'm always wrong when I make these guesses, but your brain tricks you into thinking, I knew that, when you don't write it down. At the moment you write it down, you notice how wrong you are all the time when thinking about the stuff, and it can be really fun because you don't have to tell anyone about it. Yeah, how much time is spent in your database? How much time is spent in your cache layer? How much time is in PHP? What's your bottleneck? Figure that stuff out. Like, what's the slowest route in your system? I think these can be really interesting things to look into, and I encourage you to check out one of those tools to get an understanding of your own application. Cool. Thank you so much. You can find me on the socials, and the slides will be online.
Thank you. That was really good. All right, we've got one question. There's still a little time if you do want to add some more questions. Dan asked, is there any practical difference between HR time and micro time when benchmarking?
It really depends on how fast the thing you're benchmarking is. Like, because micro time uses get time of day, like on modern Linux kernels with like VDSO time, that is not as much of a problem. But when this was still a syscall, A, that took a bit of time, and B, nothing guarantees you that time goes up. So you can call this twice and get a time that's slower than before, and that can really break your averages and your other stuff. Okay. And like with HR time, you get nanosecond resolution. So like, if you have it, I don't think there is any downside of using HR time over micro time.
Unless you use 32 bits.
If you have a 32-bit version of PHP, I wouldn't benchmark things. Yeah. I would. Yeah. Like, I don't mean this in a mean way. I just mean like, yes, this is the biggest value that you will get out of spending your time. If you're on a 32-bit system, I would recommend you to not be on a 32-bit system.
Sure. I think my question more like, if you're microseconds or nanoseconds.
Yeah.
And you measure the same thing twice with microsecond, it's going to deviate. The deviation's going to obscure any advantage from like a higher, grained.
I see what you mean.
Possibly. I tried to use it in PHP bench, but in the end, so I was still using microtime. But I didn't see a practical advantage. I mean, the monotonic things actually are really good reasons to use it.
Yeah, I think monotonic clock is enough of a reason. To do it, and there is outliers on some Linux systems where HR time is implemented in a way that you will hate yourself less. But like, it mostly by not having to figure out what the problems are. And it's been a year or two. I also forgot again. But yeah, we can talk maybe about this later and pick up some stories.
Thank you. Peter asked, is one profiler better for detecting memory leaks?
That is, I mean, yes. Like, Datadog has a really nice feature on that. The question is if you can afford to pay for Datadog.
The guy's wearing a Datadog hoodie and giggling about it as well.
And he gave a fantastic talk about profiling, and I really like the tool. So it's there's no such thing as bad PR, right? As long as the name is mentioned. No, I think that is nice, but the main question and why I'm hesitating is because the question is, what are you trying to achieve? Like in a short-running PHP process, you don't really need to figure out memory leaks because PHP will clean up. And usually when we say memory leak, what we mean is like an object graph that isn't getting collected by the garbage collector or something like that. And so there is two things to consider. Is it like a PHP memory leak in the sense of that you allocate too much memory in PHP, or is it like you call out to a C library and that actually leaks memory that isn't getting cleaned up, that you don't have a chance of getting cleaned up? So if you have a queue processor or something running like GC collect cycles before you start to process the next queue item can be very useful. Instead of doing it, letting PHP do that randomly somewhere in the middle. That's a lot faster. I think PHP Unit is also doing something like that these days, that it cleans up in between test execution so that it doesn't clean up during the test execution where there is a lot more objects that exist, because that makes things a bit slower. But yeah, if you have a concrete problem, just come talk to me. And yeah.
Cool. And then last question, Dimitri said, what should the max accelerated files upcache setting be set to? You said it should be more than 10,000. What is a good amount? And is it the amount of files in your project, including all vendor files, or something else?
Exactly. +1. Just in case you make a new file. No, but 100,000 is a safe value. I think there's nothing stopping you from doing that. But yeah, just count all the files in your project when it's built, and more than that is good. If you go to the PHP to a PHP info page, it will give you opcache statistics, or if you use the opcache function to get the statistics, it will tell you how many files are in there. And if that's close to the limit, then you should look into it.
If you overset it, does that have a performance penalty, or does it not matter?
It allocates a bit more memory, I think, but not in a relevant manner. And it only does that once because it's stored in your shared memory. So except for the fact that you spend a bunch of memory that you don't necessarily need, but it's a couple megabytes. Yeah. I don't think it's a problem.
Which is the lesser evil of not setting enough.
Yes.
Yeah. Makes sense.
Cool.
All right. That is all of you go on, I'll let you off. We've got time.
I was just going to ask, you have any experience with doing a sort of things part of the pipeline? So the sort of work is like in use sequences to check all the pipeline.
Sorry, can you define what you mean with pipeline?
As in, is it worth checking whether or not a commit pushed up has negatively affected the speed, and is there sort of a tool?
Yes. So
can you repeat the question as well? Sorry.
Thank you. Yes. So do I have experience with checking a pipeline, as in if doing performance analysis in CI? I'm going to answer a question you haven't asked first and then come back to that. So what most tools like ours and other tools do for you is that you can set a release marker, and then it will compare before and after the release. You get a performance comparison, and it will tell you, hey, these routes got significantly slower, this route got significantly faster. So that you see what your release is doing, and you can do something similar for your CI. If depending on which metric system you use, there is things I've seen people push all of their CI performance metrics to Honeycomb, and then you get for each CI run, you get a performance dashboard that looks really nice in terms of how long everything runs, or to any other metric system. And for testing how fast your code base is in CI, I think the main problem with that is that you don't have your real workload and your real user load and your real data load, and emulating that is, depending on the application, quite impossible. So measure in production and see there, and then whatever learnings you make from that, let that inform what you measure in CI. But I would start with figuring out what the reality is, and then trying to recreate that in increments.
Cool. All right. We have 15 minutes to switch rooms if you want to. But other than that, thank you very much, Volker. Round of applause.